Tonight, we're going to explore a small, cold, distant world that most people were taught to stop thinking about the moment it stopped being called a planet. Here's where we're headed tonight. A tiny, icy world, 5.5 billion kilometers from the nearest source of warmth, has an atmosphere that should be considerably warmer than it actually is. For years, nobody could explain why. The gas itself was absorbing sunlight, the same way gas always does, and yet the temperature kept coming back wrong, consistently, stubbornly colder than the physics seemed to allow. In 2017, one scientist proposed something that sounded, to many of his colleagues, almost backward. Not that something was warming this distant atmosphere less than expected, that something up there was actively, deliberately cooling it, refrigerating an entire planetary atmosphere using nothing but haze. Nobody could test the idea. The technology simply didn't exist yet. Then, between 2022 and 2025, a 6.5-meter gold mirror, unfolded 1.5 million kilometers from Earth, finally turned its attention toward that same small, distant world, and found exactly what that scientist had predicted 8 years earlier, with no way of knowing he was right. For most of the 20th century, this particular world was little more than a smudge of light, a single pixel, a footnote in astronomy textbooks, demoted, argued over, and largely forgotten by anyone outside a small community of dedicated researchers. The first surprise is that this small, distant world has an atmosphere that runs on a mechanism unlike anything else in the entire solar system. A genuine, working thermostat, apparently keeping itself deliberately cold. The second is that this same small world appears to be quietly, patiently painting its own moon a deep, rusted red, flinging invisible gas across 19,000 kilometers of empty space, one molecule at a time, for 4 billion years. And the third, the part this entire documentary is really about, is that deep beneath this frozen, distant surface, there is genuine, serious scientific reason to believe an entire ocean of liquid water has been sitting in darkness, this whole time, patiently waiting for anyone to come looking. Here's something worth knowing before we go any further tonight. Every discovery in this documentary comes from one of exactly 2 sources. A single spacecraft that visited once, briefly, in 2015, and a single space telescope, reading the faintest possible traces of light from 4 billion miles away between 2022 and 2025. No other human instrument has ever gathered data this detailed about this particular world. Everything you're about to hear represents essentially the entire sum of direct human knowledge about this place, gathered across 2 brief windows, separated by 7 years, and an almost unimaginable distance. By the end of tonight, you're going to understand exactly what James Webb actually found, why it mattered so much to the small community of scientists who had been quietly waiting 8 years for the answer, and why this frozen, distant, demoted little world might be one of the most genuinely surprising places left in our entire solar system. Let yourself settle in. There's a great deal of quiet, patient science ahead of us tonight, and nowhere in particular we need to rush toward. Here is where tonight's journey will take us. We'll begin with the strange, very human story of how this small world was found in the first place, lost, argued over, and finally, formally demoted. A story with far more nuance and far more ongoing disagreement than most people ever hear. We'll follow a single spacecraft on an almost decade-long gamble across the solar system, arriving for a single, irreversible encounter that lasted only a matter of hours. We'll meet the strange, beautiful landscape that encounter revealed. A heart-shaped plain of slowly churning ice, mountains built from frozen water, and a sky wrapped in dozens of layers of delicate blue haze. We'll sit with the genuine mystery that haze created, and the quiet, patient confirmation, arriving 8 years later, that solved it. We'll follow an invisible stream of gas across the darkness separating 2 worlds, and understand exactly how one small planet has been slowly, patiently painting its own moon for the entire age of the solar system. we'll descend carefully beneath the ice into the genuine, still unconfirmed possibility of an ocean that has never once seen daylight. And we'll end, as we always do, by turning this back toward what it means that a small, distant, once-forgotten world can still, after everything, surprise the people who study it most closely. #A sort word B4 EBE beggin. Before we dive in, if the quiet, patient mysteries of the outer solar system are the kind of thing that helps settle your mind at the end of a long day, consider liking this video or subscribing to the channel. It's a small thing, it costs you nothing, but it helps this kind of slow, patient science storytelling reach the people who need exactly this tonight. Now, let's begin. Let's begin, appropriately enough, at the moment most people assume this story ends. A single summer afternoon in Prague in August of 2006. Inside a conference hall filled with members of the International Astronomical Union, a vote was called. The question on the table was deceptively simple. What, precisely, counts as a planet? For 76 years, nobody had felt the need to answer that question formally, because nobody had needed to. Then astronomers began finding other worlds, out past Neptune, some of them uncomfortably close to Pluto's own size. And one of them, discovered the year before and nicknamed Xena before it was formally named Eris, turned out to be more massive than Pluto itself. That single discovery forced a choice nobody particularly wanted to make. Either accept Eris as a 10th planet, with the near certainty that dozens more discoveries like it were waiting to be found, steadily inflating the solar system's official planet count for decades to come, or sit down and formally define the word planet for the first time in the history of astronomy and accept whatever the definition implied. The assembly settled on 3 criteria. A planet, they decided, must orbit the sun. It must have enough mass for its own gravity to pull it into a roughly round shape. And, critically, it must have gravitationally cleared the neighborhood around its own orbit, sweeping away or absorbing any comparably sized debris nearby. Pluto met the first 2 criteria easily. It failed the third, sharing its orbital neighborhood with the countless other icy bodies of the Kuiper Belt. A new category was created specifically to hold it, dwarf planet, and with a show of hands, Pluto's 76-year tenure as the solar system's 9th planet came to an end. Here's a detail worth sitting with, because it complicates the story in a genuinely interesting way. Of the roughly 9,000 members of the International Astronomical Union at the time, only 424 were actually present in the room to cast that final vote. Many astronomers had already left Prague by the time the vote was called on the assembly's very last day. Alan Stern, the principal investigator of a spacecraft already on its way toward Pluto at the exact moment of that vote, has spent the years since arguing the decision was rushed, poorly attended, and built around a criterion. Clearing the neighborhood. That even Earth itself doesn't cleanly satisfy, given the thousands of near-Earth objects still sharing our own orbital path today. Stern advocates instead for a geophysical definition, based simply on whether a body is round and not fusing hydrogen in its core, regardless of what else happens to share its orbital neighborhood. 20 years later, in 2026, this disagreement remains genuinely, actively unresolved. Several American states have passed symbolic legislative resolutions declaring Pluto a planet within their own borders. At a 2021 public debate on the subject, an informal audience vote favored Stern's position by a wide margin, and most working planetary scientists, as distinct from astronomers more broadly, continue publishing research today using the geophysical definition Stern prefers, rather than the dynamical one the IAU formally adopted. Pluto's status, it turns out, still depends entirely on which room you happen to be standing in. A short pause here, if you'd like one. Let this particular disagreement simply sit, unresolved, exactly the way it has for 20 years. There's no need to settle it tonight. We'll continue when you're ready. There's a genuinely instructive lesson buried inside the dynamical criterion's own weakest point, worth sitting with a moment longer. Clearing the neighborhood sounds, on its surface, like a clean, objective standard. A planet either has, or hasn't, swept its own orbital path free of comparable debris. But applied strictly, even Earth itself doesn't fully satisfy it. Thousands of near-Earth asteroids continue sharing our own orbital neighborhood today, some of them large enough that, under a sufficiently strict reading of the same criterion used to demote Pluto, Earth's own planetary status might reasonably be called into question too. The IAU's own definition includes a practical, if somewhat arbitrary, threshold for how clear is clear enough. A threshold Pluto happens to fall well short of, and Earth happens to comfortably clear, but a threshold that reveals, on close inspection, considerably more human judgment call than the tidy, mathematical certainty the original 2006 vote seemed to promise. Let's rewind considerably further to understand how this small, contested world was ever found at all. Because the discovery story turns out to be stranger and more human than the demotion that followed it decades later. In 1905, a wealthy Boston astronomer named Percival Lowell became convinced that unexplained irregularities in the orbits of Uranus and Neptune pointed to a massive, undiscovered Planet X lurking somewhere in the darkness beyond them. He spent over a decade searching for it, using his own private observatory in Flagstaff, Arizona, and died in 1916 having never found it. There's a genuinely poignant irony buried in this failure, one astronomers wouldn't fully appreciate for decades. Lowell's underlying calculations were simply wrong. Neptune's mass had been slightly mismeasured at the time, and once that error was corrected, decades later, using data gathered by the Voyager 2 spacecraft, the entire mathematical justification for a Planet X quietly evaporated. Lowell had spent the last years of his life meticulously calculating the position of a planet whose only evidence for existing had never actually been real. And yet, remarkably, a real planet, or at least a real world, genuinely was discovered almost exactly where Lowell's flawed calculations had predicted, purely by coincidence. In 1929, Lowell Observatory hired a 23-year-old farm boy from Kansas named Clyde Tombaugh, largely on the strength of hand-drawn astronomical sketches he had made using a homemade telescope back on his family's farm. He had no college degree. His entire job consisted of photographing sections of the night sky on glass plates, then comparing pairs of images taken days apart using a specialized instrument called a blink comparator, hunting for any tiny point of light that had shifted position between exposures. Evidence of something orbiting close enough to our own sun to visibly move against the fixed background of distant stars. On February 18th, 1930, comparing two plates taken 6 days apart, Tombaugh spotted exactly that. A faint, barely visible speck, shifting its position ever so slightly. Lowell Observatory withheld the announcement for several weeks, finally revealing the discovery on March 13, 1930, deliberately chosen as both Lowell's own birthday and the anniversary of William Herschel's historic discovery of Uranus a century and a half earlier. The new world needed a name, and it came, fittingly, from a child. On March 14, 1930, an 11-year-old girl in Oxford, England, named Venetia Burney, was eating breakfast with her grandfather when he read her the news of the discovery. She suggested Pluto, the Roman god of the underworld, fitting for a world orbiting so far from the sun's light and warmth. Her grandfather passed the suggestion along through a colleague, and Lowell Observatory adopted the name unanimously. For decades afterward, Pluto's true size remained frustratingly uncertain, anchored to Lowell's own flawed original calculations, which had suggested a world roughly comparable to Earth in mass. Each new measurement shrank that estimate a little further. The definitive correction arrived in 1978, when astronomer James Christie, examining high-resolution photographic plates, noticed a strange, elongated bump on Pluto's own image, appearing and disappearing on a regular 6.5-day cycle. That bump turned out to be a moon, later named Charon, and its own orbital motion finally allowed astronomers to precisely calculate Pluto's true mass for the very first time. The genuine answer, once it finally arrived, was humbling. Pluto turned out to be smaller and lighter than Earth's own moon. For most of the following decades, Pluto remained essentially unreachable, too small, too dim, too distant for even the largest telescopes on Earth to resolve into anything more than a single, indistinct point of light. Reaching it would require something far more ambitious than a telescope. It would require sending a spacecraft. The road to actually building that spacecraft was littered with false starts. A mission called Pluto Fast Flyby was cancelled in the mid-1990s over ballooning costs. Its successor, Pluto Kuiper Express, was cancelled again in 2000 as NASA's budget priorities shifted elsewhere. It took a dedicated grassroots campaign, led by Planetary scientist Alan Stern, enlisting the support of the Planetary Society, students, and eventually Congress itself, to finally force NASA to formally solicit new mission proposals. In November of 2001, Stern's own proposal, developed jointly by the Southwest Research Institute and the Johns Hopkins Applied Physics Laboratory, was finally selected. The mission was named New Horizons. It launched on January 19, 2006, atop an Atlas V rocket, leaving Earth at roughly 16 kilometers every second, the fastest launch velocity of any spacecraft in history at the time. It crossed the Moon's orbital distance in a mere 9 hours, a journey the Apollo missions had once taken 3 full days to complete. Even at that record-setting speed, reaching Pluto still required an extraordinary amount of patience. In February of 2007, New Horizons swung past Jupiter, using the giant planet's own gravity to steal an additional 4 kilometers per second of velocity, the exact same slingshot technique we've explored in other documentaries from this channel. To conserve both the spacecraft's own systems and the sanity of its small ground team, New Horizons then spent the majority of the following 8 years in deliberate hibernation, waking only periodically for scheduled system checks, drifting silently through the dark for roughly 1,800 total days of dormancy. The actual encounter, when it finally arrived, lasted only a matter of hours, and came with a genuinely nerve-wracking catch. Closest approach occurred on July 14, 2015, at a distance of just 12,472 kilometers from Pluto's surface, a remarkably close pass achieved after a 9.5-year journey covering roughly 5 billion kilometers. But because Pluto sits so far from Earth, radio signals between the spacecraft and mission control required 4.5 hours to travel one way. Once New Horizons committed to its final approach, there was no possibility of any real-time correction from Earth whatsoever. Whatever happened during those critical hours had already happened, one way or another, long before anyone on the ground could know about it. There's a further complication worth understanding, because it created one of the more anxious moments in the entire mission's history. New Horizons' science instruments and its main communications antenna point in different directions and simply couldn't be used simultaneously. To actually gather its scientific data during the flyby itself, the spacecraft had to point its instruments toward Pluto, meaning its antenna necessarily pointed away from Earth, cutting off all communication entirely for the several hours surrounding closest approach. The mission's own ground team spent those hours in genuine, total silence, with no way of knowing whether their spacecraft had survived its own historic encounter or been destroyed by some undetected hazard along the way. When the communications carrier signal finally, faithfully returned at 52 minutes past midnight on July 15th, it triggered one of the more celebrated moments in the history of American spaceflight. A room full of scientists, some of whom had spent their entire careers on this single mission, erupting into genuine, disbelieving relief. A short pause here, if you'd like one. Picture that room for a moment. Years of careful, patient work condensed into a single silence, and then a single signal finally arriving. We'll continue when you're ready. The full scientific data gathered during that brief encounter took an additional 16 months to fully transmit back to Earth, trickling home at a data rate barely faster than an old dial-up internet connection across a distance so vast that even light itself needed hours to make the crossing. New Horizons' own journey didn't end at Pluto either. On New Year's Day of 2019, the same spacecraft flew past a second, considerably smaller object called Arrokoth, roughly 6.5 billion kilometers from Earth, the single most distant object any human spacecraft has ever visited. Arrokoth turned out to be a genuine contact binary, two separate lobes gently joined together at a narrow neck, having collided at some point in the ancient past at a speed gentler than an ordinary human walking pace. That extraordinary gentleness preserved Arrokoth essentially unchanged since the earliest days of the solar system's own formation, offering direct physical evidence that the outer solar system's smaller worlds formed through the slow, gentle collapse of drifting clouds of pebbles, rather than through the more violent, high-speed collisions that shaped much of the inner solar system. As of the summer of 2026, New Horizons remains healthy, having recently woken from its latest scheduled hibernation, continuing to drift outward at a distance of roughly 62 times Earth's own distance from the Sun, still transmitting data, still, in its own quiet way, still exploring. What that data eventually revealed transformed Pluto in the space of a single flyby, from a single indistinct pixel into a genuine, geologically alive world, considerably stranger and considerably more beautiful than anyone had anticipated. The most striking feature, visible even in the earliest low-resolution images, was a massive, pale, heart-shaped region, formerly named Tombor Regio, in honor of the world's original discoverer. Its western lobe, an enormous plain called Sputnik Planitia, spans roughly 1,000 kilometers across, and up close, its surface reveals something genuinely remarkable. Rather than smooth, featureless ice, the plain is broken into thousands of individual polygonal cells, each one somewhere between 10 and 40 kilometers wide, bordered by narrow troughs. This pattern is the unmistakable signature of solid-state convection. Nitrogen ice, warmed gently from below by the planet's own internal heat, slowly rising at the center of each cell, spreading outward, cooling, and sinking again at the edges, over and over, in a process that has been described, memorably, as a kind of lava lamp made entirely of frozen air. Remarkably, astronomers have found essentially no impact craters anywhere across this plain, meaning its icy surface is younger than roughly 10 million years, a geological infant, by any planetary standard, continuously repaving itself in real time. Rising along the western edge of this plain sit genuine mountain ranges with names like Alidrisi Montes, Hillary Montes, and Tenzing Montes, some individual peaks reaching heights over 3,500 meters. At Pluto's extraordinarily cold surface temperatures, ordinary water ice becomes so rigid, so mechanically strong, that it behaves less like the ice we're familiar with here on Earth, and more like solid bedrock, providing the structural strength needed to support genuine mountains, while the comparatively softer nitrogen and methane ices around them flow and deform like glaciers. And high above all of this, New Horizons captured something that surprised nearly everyone on the mission team. Images taken looking back toward the Sun, after the spacecraft had already passed Pluto and was looking back at its darkened, backlit disk, revealed an atmosphere wrapped in at least 20 separate, distinct layers of haze, extending upward more than 200 kilometers above the surface. A delicate, blue-tinted photochemical smog produced by sunlight interacting with the thin traces of methane. In Pluto's atmosphere, and colored blue by the same basic physics that colors Earth's own sky, called Rayleigh scattering, here acting on much smaller, specially structured particles. This haze, beautiful as it was, created a genuine scientific puzzle almost immediately. Instruments aboard New Horizons measured Pluto's upper atmosphere at a temperature of roughly 70 degrees above absolute zero. dramatically colder than the 100-degree temperature standard atmospheric models, built purely around ordinary gas physics, had confidently predicted before the spacecraft ever arrived. Something, somewhere in that thin, hazy atmosphere, was quietly refrigerating it, far more effectively than anyone had anticipated. And for 2 full years after the flyby, nobody could say exactly what or how. A short pause here, if you'd like one. Picture that haze for a moment. 20 delicate layers, glowing faintly blue, wrapped around a small, distant world, hiding a mystery nobody could yet explain. We'll continue when you're ready. This is the chapter tonight's entire story has been building toward. The genuine, strange discovery hiding inside that beautiful blue haze, and the 8-year wait for anyone to actually confirm it. In November of 2017, a planetary scientist named Shi Zhang, working with colleagues Daryl Strobel and Hiroshi Imanaka, published a paper in the journal Nature proposing something that ran directly against the field's existing intuition. The haze particles filling Pluto's sky, they argued, weren't simply a passive, decorative feature, coloured blue and drifting quietly overhead. They were actively, mechanically refrigerating the entire atmosphere around them. Here's how their proposed mechanism actually works, and it's worth understanding slowly, because the physics is genuinely elegant. Those haze particles do absorb some incoming sunlight in both ultraviolet and visible wavelengths, which warms them slightly, exactly as you'd expect. But these particles are also extraordinarily efficient at radiating energy back outward, specifically at mid-infrared wavelengths, meaning nearly all of that absorbed solar energy gets re-emitted directly out into the vacuum of space, almost as quickly as it arrives, essentially bypassing the surrounding gas entirely, rather than warming it the way sunlight ordinarily warms an atmosphere. The gas itself, deprived of that expected warming, settles into a much colder equilibrium than standard models, built without accounting for this specific haze behavior, had ever predicted. Zhang's team made a specific, testable prediction as part of their paper, that Pluto's disk should glow noticeably at particular mid-infrared wavelengths in a way ordinary atmospheric gas alone simply couldn't produce. At the time, no telescope on Earth or in orbit had the sensitivity required to actually test that prediction. The proposal sat there, published, genuinely compelling, and entirely unconfirmed for the better part of a decade. Then, between 2022 and 2025, the James Webb Space Telescope, a 6.5-meter gold-coated mirror operating from deep space, roughly 1.5 million kilometers from Earth, cooled to just a few dozen degrees above absolute zero, specifically so its own instruments wouldn't drown out the faint infrared light it was trying to observe, turned its attention toward Pluto. It's worth appreciating, briefly, exactly what an achievement that telescope itself represents, separate from anything it eventually found. Launched on Christmas Day of 2021, after more than 25 years of development and roughly $10 billion of careful engineering, James Webb operates from a stable gravitational parking spot called the second Lagrange point, positioned so that the Earth itself always sits between the telescope and the Sun, allowing an enormous 5-layer sunshield, roughly the size of a tennis court, to keep its delicate instruments in permanent, protective shadow. Infrared astronomy demands this kind of extreme cold, because any telescope operating at ordinary, room-like temperatures would simply radiate its own heat directly into its own instruments, drowning out the faint, ancient starlight it was actually trying to measure. Pointing an instrument this sensitive, this expensive, this carefully engineered, at a single small world 4 billion miles away to test one scientist's 8-year-old prediction is itself a genuine act of institutional patience and trust worth sitting with before we even get to what it actually found. A research team led by Tanguy Bertrand used one of the telescope's instruments to carefully measure the separate thermal light curves of both Pluto and its moon Charon, something no previous telescope had ever been able to cleanly distinguish, given how close together the two bodies appear from Earth's own vantage point. The results, published in 2025, confirmed Zhang's prediction directly. Pluto's mid-infrared brightness came in substantially higher than a bare, haze-free surface could ever produce, and higher still than models built purely around ordinary atmospheric gas physics predicted, without accounting for the haze's own separate, independent contribution. It was exactly the excess signal Zhang's team had specifically predicted 8 years earlier, with no way of confirming it themselves. Here's what makes this particular mechanism so genuinely unusual, worth sitting with directly. On Saturn's moon Titan, a broadly similar haze layer exists in its own thick nitrogen atmosphere. But there, the haze stays in a comfortable radiative balance with the surrounding gas, contributing to overall warming rather than cooling. Earth's own stratosphere is warmed by an entirely different mechanism, ozone absorbing incoming ultraviolet light directly. Pluto's specific combination: an extremely cold, extremely thin atmosphere, combined with small, radiatively efficient haze particles, combined with just enough sunlight to keep the underlying photochemistry running, currently represents the only place in the entire solar system where scientists have directly, observationally confirmed a haze layer actively cooling its own surrounding atmosphere, rather than warming it. And there's a genuinely elegant feedback loop built into the whole system, worth appreciating on its own. Sunlight breaks down atmospheric methane into simpler fragments, which recombine into the haze particles themselves. Those particles radiate heat away into space, cooling the surrounding gas. That colder gas allows more methane to condense directly onto the surface, particularly onto the same vast nitrogen ice plains discussed in the last chapter. And with less methane remaining in the gas phase, haze production itself slows down correspondingly. It's a genuine, self-regulating thermostat, one that appears to have been quietly, patiently running for roughly 4 billion years, holding Pluto's thin atmosphere close to a stable equilibrium the entire time, entirely on its own, with no one watching, until a spacecraft finally flew close enough to notice. There's a second mystery tonight's story needs to visit, and it involves not Pluto itself, but its constant companion, a moon named Charon, locked in an unusually intimate orbital relationship with the world it circles. Charon is genuinely large, relative to the world it orbits, roughly half of Pluto's own diameter, carrying about 12% of Pluto's total mass. This ratio is large enough that the two bodies don't orbit each other in the ordinary way most planet-moon systems do. Their shared center of mass, the balance point their mutual gravity actually orbits around, sits not inside Pluto at all, but in empty space, roughly 960 kilometers above Pluto's own surface. It's the only confirmed configuration of its kind among smaller bodies anywhere in the solar system, and it's part of why many planetary scientists now describe Pluto and Charon less as a planet and a moon, and more as a genuine double world, orbiting a shared point between them. Both bodies are mutually, permanently, tidally locked to each other as well, meaning Charon hangs, fixed, at exactly the same point in Pluto's sky, forever, never rising or setting, exactly the way our own moon shows only one face to Earth, except here, the relationship runs in both directions simultaneously. When New Horizons imaged Charon up close, it revealed a moon with genuinely striking, split personality. Rugged, deeply fractured highlands in its north, cut by canyon systems longer and deeper than Earth's own Grand Canyon, giving way to smoother, younger plains in its south, resurfaced at some point in the ancient past by its own icy volcanism. But the single most striking feature, visible even from a considerable distance, was a distinct, dark, reddish-brown cap sitting squarely over Charon's north pole, nicknamed almost immediately by the mission team Mordor Macula, after Tolkien's own realm of shadow. In 2016, a research team led by planetary scientist Will Grundy worked out the actual mechanism producing that dark, rust-coloured cap. And it turns out to be one of the more genuinely poetic pieces of science in this entire documentary. Pluto's own thin atmosphere is slowly, continuously leaking methane gas out into space at a rate of roughly 50 trillion molecules every second, a small fraction of that escaping gas. This thin, invisible stream drifting outward from one world gets gently captured by Charon's own gravity as the two bodies continue their close, shared orbit, separated by roughly 19,600 kilometers. Once captured, that methane doesn't stay evenly distributed across Charon's surface. It migrates, slowly, toward Charon's own coldest point. Its winter pole, where surface temperatures drop to a punishing 25 degrees above absolute zero, colder than anywhere found on Pluto itself. There, the methane freezes solid, accumulating steadily over Charon's own 250-year seasonal cycle. And once frozen in place, that methane ice gets bombarded, relentlessly, by ultraviolet light from the distant sun, along with a steady rain of galactic cosmic rays arriving from far beyond the solar system entirely. That radiation slowly breaks the frozen methane apart, and the resulting fragments recombine into heavier, more complex organic molecules. The same reddish-brown tholins we'll spend more time with in a few chapters, building up, slowly, patiently, into the dark, rust-colored cap New Horizons eventually photographed. Then, in October of 2024, a research team led by Planetary scientist Sylvia Protopapa, using the James Webb Space Telescope's own spectroscopic instruments, made a further discovery on Charon's surface: carbon dioxide and, more strikingly, hydrogen peroxide, a molecule that only forms when radiation splits apart ordinary water ice molecules on the surface, and the resulting fragments recombine in a new configuration. This is, in the most direct sense available to remote observation, a genuine chemical signature of active surface processes still happening, right now, today. Proof that Charon's frozen surface isn't simply an inert, unchanging relic, but a genuinely active chemical laboratory, quietly running its own slow reactions under the light of a sun 3 billion miles away. Two worlds, bound together for 4.5 billion years, one of them slowly, continuously painting the other. An exchange of material and color that has been unfolding this entire time, far too slowly and far too quietly for anyone to have ever noticed, until a spacecraft finally arrived close enough to see it. Let's spend a little more time with those tholins, because they carry a genuinely fascinating, slightly melancholy story of their own, one that reaches all the way back to the origins of life itself. The word tholin was coined in 1979 by astronomer Carl Sagan and his colleague Bishun Kher, borrowed from a Greek word meaning muddy, after the two of them ran an experiment sparking electrical discharges through a mixture of methane, ammonia, and water vapor, and produced a sticky, reddish-brown residue that resisted easy classification using ordinary organic chemistry. Chemically, tholins are complex, tangled chains of carbon, hydrogen, nitrogen, and oxygen. Heteropolymers, in the formal language of chemistry, built from the patient, repeated breakdown and recombination of simple molecules under the influence of radiation. On Pluto, this process begins with atmospheric methane, broken apart by solar ultraviolet light into simpler fragments, which then recombine into a whole family of related organic compounds, before eventually settling gently onto the surface as an extraordinarily slow, patient organic snowfall. Accumulating at a rate of roughly 1 centimeter for every million years, building up across the entire 4.5 billion year history of the solar system into a layer several hundred meters deep in places. Here's the detail that connects Pluto's story directly back to our own. Laboratory tholins, similar in composition to the ones covering Pluto's surface, produce genuine amino acids, the basic building blocks of proteins, and by extension of life itself, when exposed to liquid water. This finding sits at the center of one influential hypothesis for how life may have first gotten started on Earth. Comets and asteroids, themselves rich in exactly this kind of tholin-like organic material, are believed to have rained down onto a young, water-covered Earth roughly 4 billion years ago, potentially seeding our own planet's early oceans with precisely the raw organic ingredients life would eventually assemble into something living. Pluto's surface, in this specific sense, may represent something genuinely remarkable. A preserved, undisturbed sample of exactly what that delivery vehicle looked like before it ever had the chance to meet liquid water at all. And that, unfortunately, is precisely where Pluto's story runs into a wall. At an average surface temperature hovering around 40 degrees above absolute zero, ordinary chemical reactions simply don't proceed at any meaningful pace. The half-life of many organic reactions at temperatures this extreme would stretch out longer than the entire current age of the universe. Every single ingredient a prebiotic chemist might wish for is sitting right there, openly, across Pluto's frozen surface. Organic tholins, nitrogen, carbon monoxide, water ice, patiently accumulated over billions of years. The oven, so to speak, is simply switched off. Every ingredient and no heat anywhere nearby to actually cook with them. Except, as it happens, that may not be quite the whole story either, because there's genuine reason to believe an oven of a very particular kind might actually exist much closer than anyone initially suspected. Not on the surface, where the cold has held everything in perfect, patient stasis for billions of years. Underneath it. This is, in many ways, the most genuinely remarkable possibility in tonight's entire story. The serious, carefully argued scientific case that Pluto may be hiding a genuine, liquid ocean sitting quietly beneath its frozen crust this entire time. The case begins with a strange geometric coincidence. Sputnik Planitia, that vast, convecting nitrogen ice plain we spent real time with a few chapters ago, sits in a genuinely peculiar location on Pluto's surface, almost exactly aligned with the axis connecting Pluto and Charon, the precise location where their mutual tidal forces pull hardest. Ordinarily, over sufficiently long timescales, any unusually heavy region of a planet's crust will naturally migrate toward this exact tidal axis in a slow, patient process called true polar wander, while unusually light regions tend to migrate away from it. Here's the puzzle. Sputnik Planitia is a basin, a genuine depression, sitting a full 2.5 kilometers below the surrounding terrain. And yet it sits precisely where a heavy, not a light, feature would be expected to migrate. Something about this particular basin must be quietly, secretly massive, despite its obviously lower elevation. In 2016, planetary scientist Francis Nimmo and his research team proposed a genuinely elegant explanation. If the solid water ice shell happens to be unusually thin directly beneath this specific basin, allowing the denser liquid water ocean underneath to rise slightly closer to the surface than it does elsewhere on the planet, that additional density, rising up from below, could easily explain the basin's own unexpected gravitational heaviness, solving the geometric puzzle while simultaneously implying the existence of a genuine subsurface ocean. There's a second, independent line of supporting evidence, drawn directly from Pluto's own visible surface geology. Liquid water is genuinely unusual among common substances in that it actually expands as it freezes, rather than contracting the way most materials do. If Pluto's own subsurface ocean has been slowly, gradually freezing over billions of years, that continuous expansion would be expected to stretch and crack the overlying crust outward, producing what geologists call extensional tectonic features. Long, straight fractures called grabens, where the surface has visibly pulled apart. And this is precisely what New Horizons actually photographed, in the form of extensive fracture systems named Virgil Fossé and Beatrice Fossé, running alongside Sputnik Planitia's own edges. A team led by Noah Hammond modelled Pluto's entire thermal history in detail, and concluded that this specific pattern of stretching, rather than compression, strongly suggests an ocean that has not yet fully finished freezing, meaning quite possibly, that some fraction of it remains genuinely liquid today. And there's a third, genuinely striking piece of evidence sitting in plain sight on Pluto's own surface. South of Sputnik Planitia rise two enormous, unusual mountains named Wright Mons and Picard Mons. The larger of the two standing roughly 7 kilometers tall, wider at its base than most terrestrial volcanoes, each one topped with a strange, central depression and surrounded by a hummocky, crater-poor terrain unlike anything produced by an ordinary impact or tectonic process. In 2022, a research team led by Kelsey Singer proposed that these two features represent genuine cryovolcanoes. Mountains built not from erupted molten rock, the way volcanoes form here on Earth, but from repeated eruptions of slushy, semi-liquid water ice, welling up from somewhere deep beneath the surface and slowly, patiently constructing entire mountains out of what had once been liquid. What could possibly keep any water liquid at all, this far from the sun, at temperatures this extreme? The answer lies entirely within Pluto itself. Its rocky interior core contains long-lived radioactive elements, isotopes of uranium, thorium, and potassium, steadily, continuously decaying since the planet first formed, releasing a slow, patient trickle of internal heat that has never fully stopped. Combined with a natural antifreeze, most likely dissolved ammonia, capable of lowering water's own freezing point dramatically, this steady radioactive warmth may be entirely sufficient to keep a genuine ocean liquid beneath roughly 150 to 200 kilometers of overlying ice for the entire current age of the solar system. It's worth being fully honest here, in keeping with the spirit of tonight's entire story. This ocean remains inferred, not directly observed. An alternative explanation, a simply thicker layer of nitrogen ice without any ocean involved at all, could potentially account for some of the same gravitational evidence, and remains a genuine, actively debated possibility among the scientists studying this question closely. Only a future mission, carrying ice-penetrating radar or sensitive magnetic instruments capable of directly detecting a conducting layer of salty water deep beneath the crust, could ever settle the question definitively. A concept for exactly this kind of mission, named Persephone, has been proposed and would take over 30 years to reach Pluto and complete its survey. As of tonight, it remains entirely unfunded, a genuine scientific question, patiently waiting, much like the ocean it hopes to study, for someone to finally come looking. Pluto's possible ocean, remarkable as it sounds, isn't actually a lone anomaly out in the solar system's own darkness. It belongs to a rapidly growing family of worlds, scattered across the outer solar system, each one hiding some version of the exact same secret. Liquid water, sealed away beneath an icy shell, warmed by mechanisms that have nothing whatsoever to do with sunlight. Europa, one of Jupiter's 4 large moons, offers the strongest, most directly confirmed evidence of any ocean world beyond Earth. Magnetic measurements taken by the Galileo spacecraft strongly suggest a genuine, global, salty ocean, sitting beneath a shell somewhere between 15 and 25 kilometers thick, kept liquid by powerful tidal, flexing as Europa's own orbit is continuously squeezed, and stretched by Jupiter's enormous gravity. It remains the single highest priority target in the entire search for life beyond Earth, with a dedicated NASA spacecraft, Europa Clipper, currently en route, expected to arrive in 2030. Enceladus, a considerably smaller moon of Saturn, offers something even more direct still. The Cassini spacecraft flew straight through active plumes of water, vapor, and ice, erupting directly from cracks near its own south pole, and found genuine hydrogen gas, organic molecules, and dissolved salts, all consistent with active, ongoing hydrothermal activity occurring somewhere at the bottom of its own hidden ocean, remarkably similar in basic chemistry to the hydrothermal vent systems supporting life in Earth's own deep oceans. Titan, Saturn's largest moon, and Ganymede, Jupiter's largest, both show strong evidence of their own deep internal oceans as well. Titan's buried far beneath its famous surface lakes of liquid hydrocarbon, and Ganymede's evidence coming from subtle oscillations detected in its own magnetic field. And in February of 2024, astronomers announced evidence for the youngest confirmed ocean yet found anywhere. Hidden beneath the icy surface of Mima, a small moon of Saturn previously assumed to be entirely, geologically dead, its ocean estimated to be less than 25 million years old, a genuine infant by any planetary standard. Set against this growing family, Pluto's own possible ocean stands out for one specific reason, worth sitting with directly. Every other confirmed or strongly suspected ocean world in this list sits considerably closer to the Sun, and considerably closer to a massive host planet capable of generating powerful tidal heating. Pluto has no massive host planet to squeeze and flex it. Whatever heat its own possible ocean draws on would have to come entirely from its own small, rocky interior, slowly decaying, entirely on its own, with no outside assistance whatsoever. If Pluto's ocean is real, it would be, by a wide margin, the coldest, most distant, and most quietly self-sufficient ocean world so far proposed anywhere in our solar system. Kept liquid not by a powerful neighboring planet's gravity, but by nothing more than its own small, patient, radioactive heart. Astrobiologists studying this entire family of worlds are careful, consistently, to separate the question of habitability from the question of actual life. All four basic ingredients astrobiology considers essential: liquid water, organic carbon, key elements like nitrogen and sulfur, and some usable source of energy, appear plausibly present on Pluto, at least in modest quantities. But compared to Enceladus, where Cassini directly sampled genuine hydrothermal chemistry in action, Pluto's ocean, if it exists at all, would likely be considerably colder, considerably higher pressure, and considerably more chemically quiet. Described by researchers studying it, honestly and without exaggeration, as genuinely interesting, rather than genuinely promising. Not somewhere life seems likely to exist. Somewhere worth checking, carefully, simply because no one ever has. Pluto, as remarkable as it's turned out to be, is far from alone out in the solar system's own outer darkness. It's simply the first and best studied member of an entire population of similar worlds scattered across a vast region called the Kuiper Belt. And the further out you look, the stranger this whole neighborhood becomes. Eris, the very world whose 2005 discovery triggered Pluto's own reclassification, turns out to be roughly 27% more massive than Pluto itself, orbited by its own small moon, Dysnomia. Makemake, discovered the same year, carries a small companion moon of its own, found orbiting quietly, unnoticed, until 2016. Haumea, perhaps the strangest of this entire family, spins once every 4 hours, so rapidly that it's been stretched into a genuinely elongated, egg-like shape, and in 2017, astronomers discovered it even possesses its own thin ring system, an almost unbelievable find for a body this small and this distant. Sedna, discovered in 2003, traces one of the most extreme orbits of any known object in the solar system, swinging as close as 76 times Earth's distance from the Sun at its nearest approach, and as far as 937 times that distance at its farthest, completing one single orbit roughly every 11,400 years. And Quaoar, discovered in 2002, produced a genuinely puzzling discovery of its own in 2023. A ring system orbiting well outside the theoretical distance where any ring should be able to survive without simply collapsing into a moon, defying a piece of physics astronomers had considered settled for decades. Farther out still, beyond even this scattered population of icy worlds, lies something almost entirely hypothetical. The Oort cloud, a vast, spherical shell of icy debris, believed to extend outward for roughly a quarter of the entire distance to our nearest neighboring star. Astronomers estimate this distant shell contains something on the order of 1 trillion individual objects larger than a kilometer across. and not one of them has ever been directly observed by any telescope. Our only evidence for their existence comes from long-period comets, occasionally dislodged from this distant reservoir, falling inward toward the Sun on journeys that can take centuries to complete. A short pause here, if you'd like one. 1 trillion unseen objects, drifting patiently in the dark, farther from the Sun than almost anything else discussed tonight. It's worth simply letting that scale settle, rather than trying to hold it precisely. We'll continue when you're ready. There's something worth sitting with in the sheer scale of what remains genuinely unexplored, even within our own solar system. Pluto itself required 9.5 years of travel at the fastest launch speed ever achieved, simply to reach. The Oort cloud's own inner edge sits roughly 10 times farther still. At the pace New Horizons is currently traveling, reaching even the closest estimated boundary of this distant shell would take centuries more, and reaching its outer edge thousands of years beyond that. Everything discussed in tonight's story, remarkable as it is, still represents only the nearest, most accessible fraction of what our own solar system actually contains. And there remains one final, tantalizing mystery, still genuinely unresolved as tonight's documentary is being written. In 2016, astronomers Konstantin Batygin and Mike Brown noticed that a small handful of extremely distant objects out past Pluto shared an unusual, suspicious alignment in their orbits. A clustering with only a tiny statistical chance of occurring purely by coincidence. Their proposed explanation was a genuine, undiscovered 9th major planet, 5 to 10 times Earth's own mass, orbiting hundreds of times farther from the Sun than Earth itself does. As of the summer of 2026, that hypothetical planet remains entirely unfound. Though a newly operational observatory in Chile, equipped with the largest digital camera ever built for astronomy, has only just begun systematically scanning the entire southern sky, every few nights, specifically hunting for exactly this kind of extraordinarily faint, extraordinarily distant object. Whether it exists at all remains, tonight, a genuinely open question. Let's slow all the way down, one final time, and actually try to picture what standing on this small, distant, endlessly surprising world would genuinely feel like. The Sun, from Pluto's average distance of nearly 40 times Earth's own distance from it, appears not as a warming disk at all, but as an extraordinarily bright star, considerably brighter than any other point of light in the sky, yet unmistakably, distinctly dim compared to the Sun you know here on Earth. The actual light level at Pluto's own noon comes out to somewhere around 60 lux. Roughly 250 times brighter than a full moon illuminates the ground here on Earth, and, remarkably, still bright enough to comfortably read a book by. And yet, to human eyes, adapted their entire lives to Earth's own daylight, that same light would read, unmistakably, as a kind of permanent, deep twilight. Bright enough to see clearly by, and dim enough that the feeling of true daylight would never quite arrive. The sky itself, unlike Earth's familiar daytime blue, would remain a deep, midnight purple, shading toward black, even at the height of Pluto's own noon. Its atmosphere far too thin to scatter sunlight the way Earth's thick, protective envelope does. Stars would remain visible overhead, even in full daylight, something never possible standing on Earth's own sunlit surface. And somewhere above, arranged in delicate, layered veils, the same blue haze New Horizons photographed from a distance would hang overhead, especially striking and visible near the horizon, backlit gently by the distant sun. Underfoot, the terrain itself would shift dramatically depending on exactly where you happen to be standing. Water ice bedrock at Pluto's extreme cold would feel every bit as hard and unyielding as ordinary terrestrial stone. But out across the nitrogen ice of Sputnik Planitia itself, the surface would be considerably softer. Soft enough to leave a genuine footprint, which would then, slowly, patiently heal itself over time, as the surrounding ice gradually sublimated and redistributed itself around the impression. At Pluto's remarkably thin surface pressure, roughly 100,000 times weaker than Earth's own, sound itself would barely carry at all. A single footstep, crunching through the surface ice, might travel only a meter or two before fading away entirely into total, near-perfect silence. And overhead, dominating an enormous portion of the visible sky, would sit Charon, appearing nearly 8 times larger in apparent size than our own moon appears from Earth. And, thanks to that same mutual tidal lock discussed earlier tonight, permanently fixed at exactly the same position in the sky, forever, never rising, never setting, never moving at all relative to the ground beneath it. Its own dark, reddish Mordor cap would be clearly visible even to the naked eye, along with the long, dramatic canyon systems scoring its northern hemisphere. There's something worth pausing on here in the sheer strangeness of a permanently fixed moon. Every culture that has ever existed on Earth has built some part of its own mythology, its own sense of time, its own poetry, around a moon that rises and sets and changes phase, night after night, marking the passage of days and months for the entire span of human history. A civilization standing permanently beneath Pluto's own sky would have no such rhythm to draw on. Charon would simply always be there, in exactly the same place, growing neither closer nor farther, waxing and waning through its own phases as it circled, but never once rising above the horizon or setting below it for the entire length of anyone's life. Time, on such a world, would need an entirely different kind of marker altogether. In the distance, along Pluto's equatorial highlands, rise the strange, bladed ridges of a region called Tartarus Dorsa, parallel formations, several hundred meters tall, closely resembling a dramatically scaled-up version of a natural feature called penitentes, tall, spiky ice formations found in Earth's own high-altitude deserts, where they typically reach no taller than a person's own height. On Pluto, under conditions of extreme cold, extremely thin atmosphere, and geological timescales stretching across millions of years rather than mere seasons, these same basic sublimation processes have apparently sculpted formations roughly 100 times larger. An entire landscape of frozen, blade-like spires rising like some vast, alien coral reef, frozen in eternal stillness. No human being, unprotected, could survive even a few minutes on this surface. The extreme cold alone would be fatal within moments, and the near-total absence of atmospheric pressure would cause the same kind of catastrophic internal injury experienced at the very edge of Earth's own atmosphere, long before the cold itself became the primary danger. Any genuine visitor would need heavy insulation, an independent heat source, and full body pressurization, standing in a silence more complete than almost anywhere a human being has ever stood before, beneath a small, bright star and a permanent, watchful moon on a world once demoted and quietly, patiently rediscovered. Before we move into tonight's closing chapters, I want to slow down and be honest with you about exactly how much of tonight's story remains genuinely, actively unresolved. Because that honesty is part of what makes a story like this worth trusting. The subsurface ocean, as we discussed a few chapters back, remains a matter of careful inference, not direct observation. A 2021 reanalysis by researcher Noah Johnson and colleagues found that a simply thicker layer of nitrogen ice, roughly 7 kilometers, rather than the 4 kilometers originally assumed, could potentially explain much of the same gravitational anomaly without requiring any ocean at all. The ocean interpretation remains the leading, best supported explanation, backed by multiple independent lines of evidence. But it is not, as of tonight, proven beyond reasonable doubt. The cryovolcanic interpretation of Wright Mons and Pickard Mons carries its own honest asterisk as well. While the 2022 research remains the leading, most widely cited explanation for these two unusual mountains, alternative interpretations, treating them instead as unusually modified tectonic uplifts or as heavily eroded ancient impact structures, remain part of the ongoing scientific conversation rather than fully settled. And there's a genuine, currently unresolved debate surrounding Pluto's own atmospheric future. As Pluto continues moving away from the Sun along its own extremely elongated, 248-year orbit, simple atmospheric models predict that much of its thin nitrogen atmosphere should freeze directly onto the surface within the coming years, potentially causing a dramatic, near-total atmospheric collapse. But the same haze-driven thermostat mechanism explored earlier tonight may meaningfully delay, or partially prevent, that collapse from ever fully occurring. Which of these two outcomes actually happens should become clear through careful observation over the coming decade. A genuinely open question with a real, foreseeable resolution date, rather than one destined to remain unknown indefinitely. None of this uncertainty diminishes what's actually been confirmed. The haze does measurably cool the atmosphere, exactly as predicted. The tectonic evidence for expansion, rather than compression, is genuinely, repeatedly observed. Charon's surface chemistry is genuinely, actively changing, right now, under continuous radiation. What remains open is not whether Pluto is interesting. That question was settled decisively the moment New Horizons first sent back its own images. But exactly how far that interest ultimately extends, underneath the ice, into questions no spacecraft has yet been funded to answer. Let's sit with what all of this actually means, rather than rushing past it towards something more comfortable. There's a quiet thread running through nearly every chapter of tonight's story, worth pulling out into the open directly. Pluto's own scientific history is, in large part, a history of careful, patient corrections. Percival Lowell's original calculations, however sincere, were wrong, and yet they led, by pure coincidence, to a genuine discovery anyway. Pluto's original estimated mass was wrong, corrected downward, again and again, until Charon's own discovery finally settled the question. The pre-flyby models of Pluto's atmosphere were wrong, predicting a temperature the actual measurements simply refused to match. And Zhejiang's own proposed correction, in 2017, sat entirely unconfirmed for 8 full years. A genuinely elegant idea, with no way, yet, of actually being tested. There's something worth genuinely admiring in that particular pattern, rather than treating it as a story of repeated failure. Each of these corrections wasn't a retreat from understanding. It was understanding, quietly, patiently doing exactly what good science is supposed to do. Noticing when reality doesn't match the model, and being willing to sit with that mismatch, sometimes for years, sometimes for decades, until better evidence finally arrives to settle it one way or the other. Consider what it actually took to confirm Zhang's haze cooling idea. It required a completely different spacecraft, launched years after his own paper was published, requiring 25 years and roughly $10 billion of careful engineering, unfurling a sunshield the size of a tennis court in a stable orbit 1.5 million kilometers from Earth, cooled to within a few dozen degrees of absolute zero. All of it, in some small but genuine part, eventually pointed at a single small, distant world, specifically to test one scientist's 8-year-old prediction about the behavior of haze. That's an extraordinary amount of patience and an extraordinary amount of collective, institutional trust in the value of simply finding out whether an idea was actually correct. And there's something worth noticing, too, in how consistently Pluto itself has resisted every attempt to file it away as settled, uninteresting, or finished. Demoted in 2006 and still argued over 20 years later. Mapped in careful detail in 2015 and still yielding genuine surprises from an entirely different telescope a decade afterward. Even its most basic classification, planet or not, remains, honestly, unresolved, depending entirely on which room of scientists you happen to ask. Pluto, it turns out, was never actually a settled question. It only ever looked that way from far enough away. Here, finally, is the thought I want to leave you with tonight. Somewhere, roughly 5.5 billion kilometers away, a small, cold world continues turning quietly through the dark, its haze layers gently refrigerating its own thin atmosphere, its moon fixed permanently overhead, slowly being painted a deeper shade of red with every passing millennium, its possible ocean sitting in total, undisturbed silence beneath 150 kilometers of solid ice. It has been doing this, entirely unwatched, for 4.5 billion years, patiently existing, whether or not anyone ever arrived to notice. There's something worth sitting with in the fact that we did, eventually, arrive to notice. Twice, in fact, separated by 7 years and an unimaginable distance. First with a spacecraft that had to survive 9.5 years of silence and cold just to spend a single afternoon close enough to look, and then with a telescope patient enough to wait even longer, watching from a much greater distance, for the precise mid-infrared signature one careful scientist had predicted, 8 years before anyone could confirm he was right. Consider what it means that a species confined to a single, comparatively warm planet, orbiting comparatively close to its own sun, has managed to reach out and genuinely understand the inner workings of a world this distant, this cold, this apparently insignificant by any ordinary measure. Pluto offers nothing practical to us. No resource worth extracting, no destination worth settling, nothing that improves any ordinary human life in any immediate, tangible way. And yet here we are, having spent decades and billions of dollars and entire careers simply trying to understand it a little better. Not because it serves us, but because the not knowing itself felt, to enough people, like something worth resolving. That specific kind of curiosity, patient, expensive, entirely impractical, and utterly unwilling to leave a small, cold, demoted world alone simply because it stopped being convenient to call it a planet, might be one of the more quietly remarkable things our species does. You carry a version of that same curiosity yourself, simply by having listened this far into tonight's story. Nothing about Pluto changes your own tomorrow, and yet here you are, a little more curious than you were a few hours ago, about a small, cold world you will never see with your own eyes, simply because someone, somewhere, refused to stop wondering about it. So let's gather up everything we've walked through together tonight, gently, before we close. We began with a single, contested vote in Prague, and the genuinely human, unfinished story of how a small world was found, named by a child, and later demoted, in a decision still argued over 20 years later. We followed a spacecraft on a 9.5-year gamble across the solar system, arriving for a single, irreversible encounter measured in hours, cut off entirely from Earth at the exact moment it mattered most. We walked across a heart-shaped plain of slowly churning ice, past mountains built from frozen water, beneath a sky wrapped in delicate blue haze. We sat with the genuine mystery that haze created, and the patient, 8-year wait for a different telescope to finally confirm what one scientist had predicted, alone, with no way of knowing he was right. We followed an invisible stream of gas across the darkness between two worlds, watching one slowly paint the other red. We descended, carefully, honestly, into the genuine possibility of an ocean that has never once seen daylight. And we sat, without flinching, with everything that remains genuinely, actively unresolved. No dramatic, tidy ending tonight. Just an honest, patient accounting of a small, cold, demoted world that has never once stopped being genuinely, quietly interesting to the people willing to keep looking closely at it. And there is something worth carrying with you into sleep from a story built around a world most people were taught to forget about. Tonight, wherever you are considerably warmer, considerably closer to your own sun, and considerably less alone than anything currently existing on Pluto's frozen surface. And yet that small, cold, distant world is still there tonight, exactly as it has been for 4.5 billion years, its haze still quietly cooling its own sky, its moon still hanging fixed and patient overhead, doing exactly what it has always done, whether or not anyone happens to be watching. Let that be enough for tonight. Somewhere out past Neptune, 5.5 billion kilometers away, a small world continues turning in the dark, holding a possible ocean, a painted moon, and a genuinely working thermostat, quietly, patiently, whether or not you ever think about it again after tonight. You don't need to solve any of its remaining mysteries before you rest. They'll still be there tomorrow, exactly as patient as they've always been. Good night. Sleep well. And if tonight's journey gave you a little more to wonder about, consider liking this video or subscribing to the channel. It helps this kind of slow, patient storytelling find the people who need it. Thank you for spending these hours with me tonight. Good night, and sleep well under whatever sky is currently turning quietly above you.